Day 52, Honors Physics, Torque, Rotational, and Translational Equilibrium, Problem 10. It's a fairly straightforward problem. An upward force at point A, 12 centimeters from the 4 kilogram mass, which weighs 40 newtons, balances the system, so point A must be the center of gravity of the system, of this rod. And we have an unknown weight on the other end, over here, W sub 2. And you can pick any point as your point of reference once again. You could pick this as your point of reference for calculating torque, or this, which is what I'm picking, because it has a force here that will no longer contribute to the torque, so I can get rid of that. And once again, at the end of the problem, you can figure out what F is. If you know what W2 is, which we're going to get in a little bit here, W2 plus 40 will be equal to F, but they're not asking for that. That's just an extra bonus problem if you ever get that one. But the torque from point A, clockwise torque will be the W sub 2 force, the weight of that mass, times the distance from point A, 18 centimeters, because if you hold point A stationary, W2 will make the whole thing rotate clockwise this way. So you have W sub 2, that force, times 18 equals the counterclockwise producing torque, 40 times its distance, 12, and that will give you W sub 2. And once again, all the angles are 90 degrees, sine of 90 is 1, so I'm not writing that down. So W sub 2 equals some weight, but then you got to find the mass. It's asking for the unknown mass. So once again, W equals mg. Once you know the weights, you plug in there and you plug in 9.8 or 10 for g and solve for the mass.